Now let's turn our attention to storage configuration. We'll begin by exploring provisioning partitions and file systems. Then we'll move on to other more advanced storage configuration tasks such as provisioning logical volume management file systems, as well as RAID partitions and file systems. With that said, let's label this section Basic Provisioning of Partitions and File Systems. And instead of working on the local system, we're going to SSH to another Red Hat Enterprise system and provision the file system there. That system is one of the systems we've installed. So, in this section, the features include ability to provision extra storage on the fly. In other words, while the system's up and running and users are connected, and make that storage available as a mount point in the file system tree and allow users to begin writing to that space relatively quickly. And there are multiple steps involved, and we'll list those. Steps. First and foremost, you need to identify available storage. And to do so, we're going to use the fdisk command, fdisk-l, to list existing hard drives. This will give us a sense as to what has been provisioned and what has not been provisioned, and it will serve as a starting point for us to begin the provisioning process. So let's SSH over to that remote system. We'll exit this ed quota instance for the group sales, and we'll drop from root to Linux CBT, then SSH as root, since you need to be root to effect these changes on a remote system, over to the other Red Hat Enterprise system located at 75.199. It accepts us, or prompts us to accept the public key. And once we've authenticated, we'll have a shell. Now this server's name is Linux CBT serve 4. If we cat the contents of etc Red Hat release, it tells us it's 5.1, major version 5, minor version 1 of the operating system. Now once there, you can enumerate the existing storage layout using df-h. This tells us what's currently allocated. There's a root file system that's about 4 gigabytes, home about 1 gigabyte, var 2 gigabytes, boot 100 megabytes, and tempfs for dev shm, as well as swap on -s revealing dev sda6 as a ½ gig partition. So the first hard drive SDA is pretty full, and there isn't really any space free or much space free for provisioning storage. That's where fdisk comes into the rescue. Fdisk will enumerate the connected hard drives, whether SCSI, a TAPI, SATA, or what have you. So with that said, we'll clear screen reset the buffer, and then fdisk-l. It dumps the first hard drive, which is 8 gigabytes roughly, with all of its partitions, including swap. It then dumps another hard drive, which is about 10, close to 11 gigabytes, which is unpartitioned. You can tell that it's unpartitioned because fdisk returns the fact that dev SDB doesn't contain a valid partition table, so it has no indication on its drive as to the layout of the partition or partitions. So it has no partition layout, no partition table. So fdisk is the program that we want to use to create partitions. Optionally, we may use parted. Either or will do. So we've identified available storage. This returns connected storage and tells us what we may use for storage, and that may include free space on an existing disk. So fdisk-l will tell us if there's any free space. For example, it tells you the total number of cylinders, 1044, and if you follow the cylinders 1 through 13 for the first 3 partitions, which terminates at 796, the extended occupies 797 through 1044, and we have allocated up to the 992nd cylinder, leaving us between 993 and 1044 for allocation. So there really isn't much space available, which is why we want to focus on SDB, another connected hard drive. So with that said, we'll use the fdisk command followed by the path to the hard drive. So the next step is to create partitions on desired hard drive. And to do so, we'll execute fdisk followed by dev SDB for the second SCSI hard drive. In this case, it happens to be a SATA drive. So interacts with dev SDB drive as opposed to dev SDA that is, or dev SDC or some other drive. So it's fdisk dev SDB. This propels us into fdisk, returns some useful information, and if you need help you press M. However, generally you'll press P to print the partition table, and if there is none, which that is the case for us, we can create one by using N to add a new partition. So our first step is, after entering, our next step is to execute N to add a new partition. Now we know that the hard drive is about 11 gigs, 10 to 11 gigabytes. So we should determine how much space we'd like to allocate for our new mount point. We haven't determined what the mount point will be in the Linux file system tree, but that's unimportant right now. What's important is how much space we'd like to use of the roughly 11 gigabytes. So supposing we need an extra 4 gigabytes of storage. We'll indicate N to create a new partition. We need to determine whether or not it's primary or extended. As we've mentioned, when creating file systems on a PC, partitions on a PC, you need to always bear in mind that there's a limitation of 4 primary partitions, or optionally 3 primary and 1 extended, or up to 3 primary and 1 extended. Within the extended partition, you can create a large number of logical partitions to further divide your storage. So since this is the first partition, we'll make it a primary partition. We then need to pick a number. Well, since it is again the first partition, we'll default to number 1. You also need to determine the cylinder, the first cylinder. You can create a partition using fdisk anywhere in the disk. It doesn't need to be at the beginning of the disk. You could start, let's say, at cylinder 100 and stop at cylinder 199 if you'd like. We'll start with 1, that's the default, and then you indicate the size of the partition using plus followed by one of the following: megabytes, gigabytes, kilobytes, so on and so forth. Now we want this to be 4 gigabytes, so we could indicate plus 4096 megabytes, which is equivalent to 4 gigabytes, or plus 4G. Either or will do. Since we know that the exact number of megabytes is 4096, since we are moving in increments based on base 2, so 1024 would be 1 gigabyte, 2048 would be 2, and 4096 would be 4, we'll indicate plus 4096 megabytes. When you specify the total storage using this format, fdisk handles the allocation of the cylinders, so it performs the math to determine the last cylinder that should be used to achieve 4 gigabytes worth of storage. Now if we reprint the partition table, you'll see that there's a new partition, SDB1. The hard drive is SDB, the first partition is SDB1. So new, next step is we need to indicate that it's primary or extended, followed by 1 for start cylinder, followed by, in our case, plus 4096M to indicate 4 gigabytes out of the 10 to 11 that are available. But these changes have not been written to the disk just yet. These are just temporary interim changes. In order to commit the changes to the disk, execute M for help, and you'll see that writes the changes to the hard drive. So W updates the partition table. You may optionally create additional partitions, but we'll do that later on when we show you how to create swap partitions and swap files or swap file systems based on files and partitions. So again, we've created a new partition, and by default fdisk defaults to type Linux. type 83 or ID83, which is type Linux. This is the type of file system that we need, or type of partition that we need to create a standard Linux file system such as Riser, ext2, or ext3. However,